Another type of discrete distribution is called the negative binomial distribution or Pascal distribution. Consider an experiment similar to a binomial experiment, but instead of having x successes in n trials, we look for the probability of having k success in a total of x trials. This is called negative binomial experiment, and it's written as B star. B as in binomial, but we put a star here, B star XKP. Random variable x represents the number of trials which results in k success. Success in a negative binomial experiment is called negative binomial random variable. And the formula for the probability is here, B star x. The probability that x equals x, or B star x, is x minus 1, choose k minus 1, p to the k, q to the x minus k, where x starts from k minus 1. X can be anything from k minus 1 up until whatever. The formula is derived from counting principles. Okay, this is the counting principles. We make use of some combination, and we use the union of some events, and you get this formula. The mean of the negative binomial distribution is k over p. This is derived from the definition of mean. And the variance is kq over p squared. You might not understand what exactly it is again. We look for the probability of having k success in a total x trials. Like in here, what? Here, toss 2 coins for 5 times. Determine the probability of getting both heads for the 3rd time on the 5th toss. This is a negative binomial experiment, okay, because we want to find the chance of getting success. Success means getting both heads. We want to find the chance of getting success for the 3rd time on the 5th toss. So x equals 5. K is equal to 3. Getting success for the kth time. Getting k success in a total of x tosses. Okay. Getting success for the 3rd time on the 5th toss. And the probability of success, probability of getting both heads are 1/4. All right, head and head. Okay, and the formula is x minus 1, choose k minus 1. P to the k power Okay. Okay. P to the k power and q to the x minus k. X is 5 minus 1, k is 3. 3rd toss. at the third time, getting success for the third time on the fifth toss. P 1/4 raised to the third power, and Q x minus k 5 minus 3, and that is 0.5 okay. Actually, what does it mean here? Toss 2 coins for 5 times. Determine the probability of getting both heads on the third time on the fifth toss. So it means you're tossing 2 coins for 5 times. These are the results. Okay, the outcomes could be getting both heads or something else. We want to find the probability of getting both heads for the third time on the fifth toss. This is the fifth toss. Getting both heads for the third time. So it means that here is the outcome of getting both heads for the third time. That means there are 2 more outcomes previously that you get both heads. You might get it here, 1, 2, and 3. Okay. Or you might get it here, 1, 2 here, and the third time is here. Or you might have 1 here, 2 here, and this is the third time that you got both heads. Both heads here, both heads here, both heads here for the third time. And it happens on the fifth toss. Alright. Or it might be here, this one and this one. One time, both heads here, both heads here, and both heads here. So you don't care about the previous outcomes. You only care that on the fifth toss, you got success for the third time. Okay, success for the third time. So it means in the previous times there must have been 2 successes. 2 successes must happen previously, but we don't know where it is. We just want to know the probability of getting success for the third time on the fifth toss. All right. So we just say 2 successes happen previously. Anywhere in here there are 2 successes, and here is the third success that happens in the fifth toss. So in this type of situation, we use negative binomial experiment. All right. In real life, we don't use it a lot because it's very particular. But I just want you to know that there is something that you can use, some situation. The reason that this is called negative binomial is because it comes from mathematical expression. It comes from some sort of binomial expansion. Now, the last type of distribution is called geometric distribution. No, almost the last one. Geometric distribution is negative binomial distribution with if x is a random variable that represents the number of times the trials end with success for the first time, then the probability distribution follows the geometric distribution. So consider the case that k equals 1. All right, k equals 1. It means you got success for the first time in x tosses. Here you got success for the first time in X tosses. In X experiment, you got success for the first time. Your formula, this formula, when K equals 1, what happens when K equals 1? This formula is going to be shortened. When K equals 1, Px will be X minus 1, choose 1 minus 1, P to the 1, Q to the X minus 1, right? And that is equal to PQ to the X minus 1. And this is called geometric distribution. Geometric distribution. Okay? With me? You're with me? Geometric distribution is P times Q to the X minus 1. Alright? If the experiment consists of several trials, which are independent of one another, and each has probability of success equals P and the probability of failure equals 1 minus P or Q. And if X is a random variable that represents the number of times the trial ends with success for the first time, then X follows the geometric distribution and this formula. The mean is 1 over P, and this is variance. Let's see this. It'll help you to get the picture better. A scientist wants to cultivate bacteria in several rats by injecting culture into each rat. After each injection, he checks whether the rat is infected. If it is, he stops doing the experiment. Okay? If the probability that each rat is infected is 1 in 5, determine the probability that the scientists use only 6 rats in this experiment. This situation is geometric situation. Why? Because the success here, the experiment has 2 outcomes, right? Success and failure. Success means infected. Rat is infected. And it's about doing the experiment until you get success for the first time. That is geometric experiment. Okay? You do the experiment until you get success for the first time. X represents the number of experiments or the number of times you do the experiments until you get success. So here it's about geometric experiment. You want to know the probability of scientists using 6 rats in this experiment. If he's going to use 6 rats in the experiment, it means that the 6 rats is a success. 6 rat is the 6th rat. Rat number 6 is a success. But the 5 rats earlier are failure. They're not infected. Okay? If he's going to use 6 rats, it means the 6th rat is the first rat that is infected. Okay, it says here, because it says, if it is, after each injection, he checks whether the rat is infected. If it is, he stops doing the experiment. Alright, so this rat is okay. Not infected, not infected, not infected, not infected. Infected, so he stops the experiment. So here he's using 6 rats. Right, so geometric experiment where X equals the total number of experiments done to get the first success, okay, to get the first rat that are infected. X equals 6. The probability of success is 1 in 5, 1/5. P is 1/5. All right. So the probability that there are X experiments that needs to be done to get the first success is G6 equals PQ to the X minus 1. P is 1/5 and Q is 1 minus P. Okay? X minus 1, right? 0.0655. All right, 6%. There's a 6% chance that the scientists use 6 rats in this experiment. Okay. Giving you another example, like สมมติว่าเราอยากไปจีบผู้หญิงอะ Sorry for speaking in Thai. I will do it in English later. สมมติว่าเราอยากจะจีบผู้หญิงนะคะแล้วอยากมีแฟนอะเราจีบผู้หญิงไปเรื่อยๆแล้วมันไม่ติดสักทีอยากทราบความน่าจะเป็นที่ต้องจีบผู้หญิง7 คนถึงจะจีบติดอย่างเงี้ยเป็น geometric experiment เข้าใจป่ะอยากทราบความน่าจะเป็นที่ต้องจีบผู้หญิง7 คนถึงจะจีบติดก็แปลว่าก่อนหน้านั้นไม่ติดเลย success เป็นคนแรกในครั้งที่7อย่างนี้เป็น geometric โอเคป่ะอันนี้คือตัวอย่างในชีวิตจริงง่ายๆพอเข้าใจไหมคะ I was giving some example about dating. You want to date someone, you want to have a girlfriend, and you want to find the probability of asking 7 girls before you get a girlfriend, and that is geometric experiment to find the probability of asking 7 girls to get a girlfriend, and that means the first 6 girls are not success. You're not successful with the first 6 girls, and the 7th girl is the success, so you get her as a girlfriend. That's geometric experiment. The chance of getting success for the first time, and X represents the total number of experiments done. Okay, this is the total number of experiments done. X is 7. You have to do it 7 times to get success for the first time. All right. Questions? A grocery product company markets 175 different products. Data indicate that there is a 20% chance that in any one year, legal proceedings will be initiated by a consumer or distributor against the company concerning any one of these products. A new product is to be introduced. Compute the probability of the first lawsuit in the 3rd year of marketing. Now, this is a geometric distribution. Find the probability of the first success in the 3rd year of marketing. Find the probability of getting the first lawsuit in the 3rd year of marketing. That means you market the product, you launch the product. First year, nothing happens. Second year, nothing happened. But in the 3rd year, you got the first lawsuit. Okay, so that is geometric experiment with x equals 3, right? Find the probability that x equals 3. And the probability of getting a lawsuit is 20%. There's a 20% chance that in any one year you will be sued legally. So P is 20%. Okay. Geometric 3. P is 0.2. Right? PQ to the x minus 1. P is 0.2. Q is 0.8. X is 3 minus 1. Okay? and you have 0.128. There is a 12.8% chance of being sued for the first time in the third year of marketing the product. This distribution is used more often in practice, especially in science, like in science experiment, in laboratory, when they want to do something like cultivating bacteria or something like that. All right. Compute mu and sigma for the distribution. Mu is Ex, and according to the geometric distribution, Ex is 1 over P. You can prove that by using the definition of expected value, but we didn't show it in the lecture note. We didn't want to spend time on the proof, so let's just apply it. 1 over 0.2. What is that? 5. What's the unit of mu? Unit ของ mean คืออะไรคะ What is the unit of mu or Ex? Expected value of x. Unit is the same as x. What is x? What is x? Let x be what? What are we talking about? Lawsuits, right? No, x is the years. X is the years that the company is sued. The year that you got success. The year of marketing the product. X is the year, so 5 years. X is the years, number of years of launching the product. X represents the number of years of launching the product. You want to find here the probability of launching the product for 3 years until you get the first lawsuit. E of x, expected value of x, has the same unit as x, so 5 years. On average, the company launches a product for 5 years until they get the first lawsuit. On average, they get their first lawsuit on the 5th year of marketing. Okay, the first lawsuit happened in the 5th year of marketing on average. Right? Sigma is the square root of variance, square root of this term, q over p squared. So that's square root of q over p squared. And that is, q is 1 minus p over p squared. So that is 0.8 over 0.2 squared. 4.5 years. Sigma has the same unit as x. Right? Questions? มีคำถามไหมคะ Are there any questions? Okay, I'm going to finish with the last type of distribution. The last type of distribution is called uniform distribution. When you talk about uniform, you think about what? Same form, right? The same form. Everything is the same. Uniform distribution is a distribution that has equal probability over some values of x. Uniform distribution, in uniform distribution, x has equal probability. Oops. If this is x and this is the probability, x will be uniform if the probability is the same. Same probability. Same probability over a certain value of x. So this is probability, same here, over x between a and b. You call it uniform distribution. Probability is uniform over a certain range of x. Okay? The probability of having x, the probability that x equals to x value can be found from 1 over b minus a plus 1. And b is here, the higher limit, and x is the lower limit. Okay, this is the probability of x. The probability that x takes on the value of x. Right? And the mean and the sigma is given in this equation. The mean is a plus b divided by 2. The sigma is square root of variance. Example: 911 emergency has 22 available lines. If the probability of each line being used is uniform, that means that the probability that each line being used is the same. It's equal probability for all the 22 lines. Find the mean number of lines being used at a time. Find the mean number of lines. Let x be the number of lines being used. Find the mean of x. Ex, or mu, okay, is a plus b over 2. We know that the lines are uniform. The lines have uniform probability. So from line 1 to line 2, line 1, line 2, line 3, line 4, line 5, 6, 7, up until line number 22, they all have the same probability of being occupied. Okay, so a is 1, b is 22, and mu would be 1 plus 22 over 2. Lines. The average number of lines being used at a time is 11.5. Okay. So that's uniform distribution. You use it when there are equal probabilities of occurring for x for a certain range of x values. If they have equal probability, then that would be uniform. By the way, this is for discrete distribution. Okay, uniform here, we're talking about discrete uniform. If it is a continuous variable, we also have uniform distribution, but we're going to use different formula, a slightly different formula. So this chapter 3, is about discrete distribution. Okay, discrete distribution. That means that we are talking about discrete variables that can take on separate values, distinct values. And we looked at the general type of discrete distribution. That when I say general, I mean there is no formula for them. You just have to devise your own way of looking for the probability according to the situation. We also looked at specific type of discrete distribution. Okay, and there are many of them, many types of discrete distribution that are common in statistics. We discussed the binomial distribution, hypergeometric distribution, multinomial, Poisson, uniform, negative binomial, geometric distribution. So there's a lot of things. There was a lot of things that we learned on this subject. Okay, specific types of discrete distribution. In this specific types, you need to analyze by your own judgment if it fits with the situation described for the binomial or for the other things. You must know how to analyze it. Binomial, hypergeometric, and whatever. Okay. And for each type of distribution, for each of these type of distribution, what you should know is the three formulas: the formula for fx, the formula for ex, and the formula for the variance. All right. In some of the distributions that we are not focusing, we didn't tell you these because we don't want to spend too much time on that. But you can find it in other sources. But anyway, I'd like to tell you that this is what we covered in chapter 3. Are there any questions? มีคำถามอะไรไหมคะ No? ไม่มีคำถาม Okay. So if there's no question, then I'll see you next week. Next week we still have lectures. Okay, the midterm is postponed to the end of the month. So next week is a regular lecture plus regular quizzes. Okay, so see you next week. Have a good weekend.